Some more things to be aware of. So this is an example where we have some sort of base class and some sort of derived class. Just an idea that there could be conversions, upcasting situations that we have to recognize. So once again, there's a base class, there's a derived class, and there's some functions. Okay, so we'll examine them one by one. So we have both of them are created. So we have the base class and the derived class. So let's make a little drawing of it. So when we construct the base object, okay, so this will be a box like this. So this is the base. And when we construct derived, okay, so it will be, of course, the base, once again, will be a part of it internally, but the derived here will have its own box around it. So this is how the derived looks like. Okay, so we have constructed two of these objects, and inside the derived there is a base. And we call function e, and we pass the derived class, instance of the derived class, this box, to a function which is expecting the base. And for the compiler, it's called upcasting. It just thinks that, okay, I do have the base class right here. It's no big deal. It's essentially what I need to give this function is a copy of this internal part of the derived. So it's trivial. So it will make a copy of this, all right, because this is not using references, this is not using pointer. So essentially what's going to happen that the compiler will write the code to make a copy of the base class right here, right? This part will be an exact copy, and this function will get access to the exact copy. Okay, so this is okay. And it's called implicit conversion via upcast. And upcast means that derive always includes the base. Okay, so next example, we have function f, which is now expecting the pointer, a pointer to the base pointer. So same thing, compiler will realize that there is a base class, we try to pass the derived class to this function that expects pointer to the base. We take address of the derived, but the compiler will, of course, this address of the derived, let me just clear this and redo it one more time. So this is the base class, and there is a derived class that is built around it. And of course, when we take address of d, which is the derived, initially, obviously, we understand that this is the address of this outer object. But compiler realizes that this function doesn't really need this big object. All it needs is this. So it basically adjusts this address to point to the internal part, the base part of the derived object, and this is what this function will get. It's just going to get this this pointer. The address of this object will be passed to it. Very similar situation with the reference, right? So function g expecting reference to base, but we have the derived object, and it'll just, instead of passing this object, it will pass a reference over here. When we invoke function g, this reference will be, of course, pointing to the inner part of the d. So in all these situations, in all three examples, it's trivial for the compiler to essentially go from the outer box and realize that the inner box is always present there. So anytime some other part of the program is expecting to get the inner box, the outer box supplies it very easily. The code will compile and everything will be okay. Now we have a situation with function h, which wants a pointer to the derived object. Okay, so of course what this function is expecting here, right, is a pointer to the derived object, which looks like this. It's a big box, And yes, internally it has the base, but okay. So it gets it is expecting pointer to this big object. And then we pass b, which is the base, right? So the base is only a small object, and it's only the base, like this. And we're trying to give an address of this object, right? So we just say take address of this object and pass it, basically fool the compiler by trick it by making it accept pointer to the base, but it has no big box, so so this is not accepted by the compiler, and of course this will be an error of incompatible types. Okay, just be aware of it. But upcasting, the idea of upcasting, and this involves, you know, copying objects and passing addresses or references. So anything that's already included in the outer class, in the derived class, is okay. It's just trivially done by the compiler, and we don't have to do any kind of explicit casting in these three situations. And the third one is an error.